Happy birthday, Stacy. Okay, so we're going to wrap up section 8.1. We're still talking about inverse sine, cosine, tangent functions. Let me just get right into some examples for your homework assignment. And here's what you're being asked to do in 37 to 44. You're not using calculators here, and in some cases these are going to be very easy. Let me just go back in time for just a minute. We talked about how we know whether two functions are inverses of each other. And if we can take the inverse, that's what this denotes, the inverse. If we can take the literal inverse function and plug it into the original function and the result is x, and then we do that same thing in the other direction, take the original function and insert it into the inverse and get the same result, we did this a few weeks ago, then they truly are, these two are inverses of each other if they pass this little test where x is the result in both cases. Well, that's kind of what we're doing here. Here, notice I've got the inverse and I've got the, what we'll call maybe the original. And as long as this number, now it's in radians, as long as it fits the criteria that we talked about the other day where, remember for cosine, for inverse cosine, we're only looking at the top half of the unit circle. And so x, to represent the top half, x has to be between 0 and pi. As long as that number is in this area between 0 and pi, then the answer is that number. So it's going to be pretty simple. My answer for letter A, since 4 pi over 5 does exist in this between 0 and pi, then that's my answer. So my answer for letter A is 4 pi over 5. So the trick here is for cosine, you just want to make sure that the given number does fall in the 0 to pi area. Okay, well let's look at another example where it doesn't fall within the prescribed area. Okay, remember sine, and I went ahead and put the unit circle on here for you. For inverse sine, where are we looking for answers to inverse sine functions? What part of the unit circle? The right half, okay, and that's also true for tangent. All right, and we had a little discussion the other day as to why. It's all about restricting the domain so that we can get an inverse function out of the original sine graph. Well, the problem here is that 9 pi over 8 doesn't fall in this area. So I can't just say my answer is 9 pi over 8. 9 pi over 8 is the same thing as saying 1 1/8 pi. Okay, so I'm just going to do a little rough sketch. Maybe I'll just do a different color to make it stand out. Okay, so here's 1 pi, and then here's another 1/8 pi. So obviously, that falls outside of the required area for inverse sine. So what do we do? Okay, well, first of all, let's think about what sine is in this quadrant where I've drawn this blue terminal side. What is sine? What is the SIGN of sine in quadrant 3? Negative. Okay, so here's what we're going to do in cases like this. Remember reference angles? The reference angle for 9 pi over 8 would be this little deal right here. It's the difference, it's that angle that's formed between the x-axis and my blue line. And what is that angle between the x-axis and my blue terminal side where I've got the two double lines? What is the measurement of that angle in radians? Well, let's see. This is pi, 1 pi, and this is, or 8 over 8 pi, and then I went 9 over 8 pi. Pi over 8, okay? So here's how we're going to have to come up with the answers when the original radians falls outside of the prescribed area for sine or for tangent or for cosine for that matter. I'm going to use the reference angle, which we've already established as pi over 8, and then I'm going to use the same sign, S-I-G-N, that the sine is in quadrant 3. What is sine in quadrant 3? Negative. So put it all together, my answer for letter B is going to be negative because that's the sine coming out of quadrant 3, and pi over 8 because that's the reference angle. Negative pi over 8 would put it in the prescribed area for inverse sine. So does that thinking make sense? If you need to just go ahead and draw what's given, hey, that's not where sine, inverse sine is supposed to be. It's supposed to be on the right half. So use the reference angle and then think about making it the same sign as where this was when you drew it. All right. If, for example, if I had an angle that came into quadrant 2 for sine, well, in quadrant 2, sine is positive. So I would be thinking about an angle that would be in quadrant 1 where sine is also positive. Okay, does that make sense? Any questions? All right, so let's take a look at a tangent example. So once again, your first thought should be, is 4 pi over 5, again, we're thinking about inverse tangent, and for inverse tangent, the numbers that we're looking for have to be on the right half of the unit circle, okay, just like sine. Is 4 pi over 5 within this negative pi over 2 area? Well, if you're not really sure, what I've done here is I made it in denominators of 10, and let's do the same thing for 4 pi over 5. If I made this a denominator of 10, it would be what? 8 pi over 10. Okay, so now you can kind of see, if you put it in consistent units, consistent denominators, does 8 pi over 10 fall in this area? No. 8 is not between negative 5 and positive 5. So I just did this so in some cases it's hard to tell. Does that given angle fall in the range between pi over 2, negative pi over 2? And you might have to do a little denominator conversion to make it make more sense. Okay, so what's the reference angle for 4 pi over 5? Pi over 5, okay? Now, if we drew 4 pi over 5, if I just said, show me where 4 pi over 5 would, where would the terminal side of that angle fall? Which quadrant? 4 pi over 5. Okay, so I'm starting here, and tell me when to stop. Okay, I would be 5 pi over 5 would be, Stacy can't see that, so I don't know why I'm doing it on the board. 5 pi over 5 would be all the way over here. So I need to stop a little bit short. So I'm in quadrant 2, right? And what is the sign of tangent in quadrant 2? Is it positive or negative? Yeah, because sine over cosine, sine is positive but cosine's negative. So tangent is negative in quadrant 2, so putting it all together, we use the reference angle pi over 5, but we make sure that it's negative because when we sketched 4 pi over 5, that terminal side fell in quadrant 2. Tangent is negative in quadrant 2, so therefore my answer has to also be negative. And so really we're looking at, instead of 4 pi over 5, which fell outside of this area, negative pi over 5 definitely does fall within the area. So it's a combination of finding the reference angle and then making sure you choose the appropriate sign for the function. Okay, so we move to a different type of problem. And we're finding the exact value. These are composite functions. It's think of a function, which is really the inverse inside another function. And that same idea is true that we looked at before, as long as this domain number falls within the prescribed domain for inverse sine. Remember, for inverse sine, the domain is going to be the range for sine. Sine, the original sine function had a range of +1 to -1. So the range of a function becomes the domain for its inverse. So now the domain has to be, since inverse is now located on the inside, we have to have a number between -1 and +1 for it to actually have a value. If there is no value, we're just going to label it as undefined. All right, so for sine and cosine, the value must fall between -1 and +1, inclusive. For tangent, it's any real number. Remember, for the tangent graph, it goes forever and ever, both up and down. And when you sketch it, which that would be the range for tangent, so the domain for tangent would be that same set of numbers, all real numbers. Okay, so 1/4 in this case definitely falls between -1 and +1, so that just becomes my answer. So it really boils down to this on problems 45 to 52. If the number falls within, for sine and cosine, -1 and +1, that number will be your result. If it doesn't, then it's undefined. And then for tangent, it'll be whatever that number is, because the domain is essentially all real numbers. Okay, once again, the domain for inverse cosine is between -1 and +1 inclusive. 1.5 obviously does not fit, and so this is going to be one of those that is undefined. Okay, and then we get to our last type of problem, and you're actually going to be solving some equations involving inverse sine, cosine, tangent. And here's a really good way to start thinking. You always want to isolate the inverse trig function first. So to do that, since 4 is being multiplied, I'm just going to divide both sides of this equation by 4. And that leaves me with inverse sine x is pi/4. And to solve for x, just think about what you did in the past. If, for example, change colors here, if this were 4/5, you would multiply by 5/4, which would be considered the inverse. And so essentially, to undo inverse sine, just think of doing sine on both sides. And that serves that purpose, and we're left with x equals sine pi/4, and you can go to your unit circle and look up pi/4, and it's the y coordinate of that point on the terminal side that intersects the unit circle, and that's square root of 2/2, which will be my answer. And let's do one more of those. We need to isolate this time inverse cosine x, and so we need to gather those onto the same side. So that looks like this. I'm going to subtract 2 inverse cosine x, and then I'm going to add 2 pi since it does not have inverse cosine as part of it. I put my like terms on the same side. And then I can combine these like terms. 4 minus 2 is 2. Inverse cosine x is 2 pi. And now I'll divide by 2 on both sides to isolate inverse cosine x. And just like we did before, we're going to be solving for x by doing cosine on both sides. And again, on your unit circle, cosine pi is -1, and so that ends up being the answer for this example. But that's the process. You want to isolate the inverse trig function with x. You're trying to solve for this number, obviously x, by isolating the inverse trig function. And that's it. And this is the assignment that we'll check next time. And if you have any questions, let me know. That makes